Hello everyone and welcome back. This is the usual stream for writing a programming language in Rust. I'm going to, like yesterday, just dive right in. I did a little bit of messing around in the meantime because it was bugging me that there was this issue with the implementation of, assignment, or at least the updates in how assignments were handled were flagging some issues in different parts of the code that really weren't making sense, such as this part in particular. We had this issue with parameter mutation where we would mutate a value inside a function, and then after the function returns, the mutation we made on the parameter object wasn't persisting. But what was also kind of strange was that if we created that property before we called the function, then it would actually work as expected and the change would persist. So we can see there on the right that the test actually passes now that we added that value. And so because of that issue, I was playing around with different scenarios to see what else, were there other similar scenarios that could trigger the same issue, and I found that there was. So I created this, shall we say, simplification where I was assigning x to another. I was creating an object, assigning it to x, and then assigning x to another value or variable y, and then doing the update that way. And we would expect x to be updated here to contain age 30, but we can see on the right hand side again that the original object x is unchanged, but if we take a look at y, we will see that y is actually changed. So there is a change happening, just not on the source object, and or rather not necessarily the source object, but the original object that we created. And I also wanted to get another data point to see, does this issue also occur with lists? So if I do something like this and assign to the first index, so if I have index value 1 here and I update y to 2, does the issue persist in this scenario as well? So is it all references essentially? And the answer is no. So it actually works when we use lists. So using these examples, we can kind of narrow it down a bit and say that it really only affects objects, and only affects objects when we're performing an assignment, as we've seen before, when we actually have the property already assigned, then the change persists, or it propagates to the original object. Well, not propagates, it actually affects the original object. So we can see that this basically pertains to assignment rather than declarations of properties. So with that, I'm just going to jump to the train of debugging that led to my figuring out what the issue was. I mean, it got to the point where I was thinking, will I install an AI LLM interface in my IDE to see can it figure it out, because I was kind of getting stuck. But what I was able to do was a few little bits. First of all, I updated scope because I was really wanting to see, okay, what objects are being affected at each step of the process here. So clearly X and Y seem to be independent objects at this point. That was the only thing that was making sense as to why the change in the second one wasn't affecting the first one. Surely they should be the same reference, or at least two references to the same object. So one thing that I did was, let's see, it was in scope and it was in bind. So first off, in the section where we're outputting, or where we're performing the assignment to the object, when we find out, so at this point we've dereferenced the object, and we have the, shall we say, raw, well, it's not a hash map, it's technically a B tree, but essentially the mapping from strings to values. Once we have that, we output the item itself, and then this directive in Rust for format parameters gives the address of the object itself. So if I go ahead and compile that, we can see this should basically only output one object, because it will output it for this. It'll say what object is being affected. So we can see before the assignment, we can see before the assignment we have the value 20 in the object, and in fact I'll remove this so we're back to the failure, but we could see before that the object was 20, and we can see the address down here of the object. And I believe I also wanted to output it after the assignment as well, so that I can see, okay, is something funny happening in between, and is the address consistent? Do the changes actually get made to the object? And we can see that they do. So before the assignment, the object is empty, and it's FE8 is the address of the object, and we can see that's the same object afterwards as we would expect, except now it has the 8 property assigned. Now, what I thought would be more complicated than it ended up being was to actually check whenever we do a variable lookup in the scope and actually retrieve it from the global scope, what value is actually being retrieved. So in essence, when we look up y down here, when we look up x down here, are the objects that those are referring to actually the same object, or are they different? And I did some extra adding of debugging symbols around here. So what I did was I did a match on, I believe, the value here, and I need to import value to be able to do that. And so we output, hi, Scripterven, nice to meet you, thanks for the message. So at the moment I'm just debugging so I'm working on a programming language called Seed. It's intended to be a research language, and there was a bug, or there is a bug with, we can see over here, there was a test script that I was working on where I would create an object, pass it as a parameter to a function that modified the object, but then when I printed out the object afterwards, the change wasn't persisted. So I'm just digging into so I have actually resolved it last night, and I just want to go through the debugging process and show how I was able to get it solved. Thanks for the question. And so we can see here that I'm outputting the object that is being modified before and after the modification happens using this assignment statement. And the second part of this is to, whenever we do a retrieval of a value from the scope, we print out the value and address of the object being referenced. And I'll go ahead and save that. And then the final thing was just to add again some debug symbols around the place so that I could keep track of what step in the process we were looking at. So if I go ahead and recompile all that, and it gets rerun, so that's not in valref with source, that's right. So I have to look at the actual value contained in v. So v itself is the valref with the source, and we just want to look at the value component of this. And that's a mutex guard, so I probably have to do a deref and reference to dig into the object being referred to, I believe. Yeah, so I can skip that. Just do a no op for any other patterns that get matched there. Great stuff. So with that all done, we can see now step one, between step one and between line, we'll informally call them, yeah, I guess for this statement anyway, between the first and second print, we don't have any output because this is a declaration on an assignment, and we're not actually doing a variable lookup here because it's creating the variable. Between lines 2 and 3, we can see the lookup of x. So this is going to be the in-memory address of x. So it's something like 4D88 is that one. And that's being assigned to y. And then on line 3, there are going to be three debug outputs. There's going to be the before and after of the assignment statement, and there's going to be the lookup of y in the environment. So first we have the lookup of y, and already we can see that when we get the value y from the environment, we can already see that this is different. The object that y refers to is different to the object that x refers to. And it took me a little longer to find this, but now that I know what I'm looking for, I can see it there quite clearly. So there's an issue there that the object y is different to the object x. So when I update one, the original isn't getting updated. So in theory anyway, something is most likely getting cloned instead. So the value itself is getting cloned rather than the reference to the object. And maybe just to illustrate that a little, I will pull up my tablet. So let's see, present this. Will this work for me today? Yes. So let's go ahead and pull this up here. So essentially what we're saying is, we'll just change the template there for the moment. So we have our B tree, and this is going to be, and I just noticed as well, is there any this is a bit off topic, but is there a pen that I can use that looks a little smoother? Those look a little clunky on the screen. Let's see. Mechanical pencil, no. Highlighter, ballpoint pen maybe. That's a little smoother, but I think it looks like the marker might make the most sense. And I think if I zoom in a bit, it probably makes it a little bit smoother as well. Okay, that's a bit smoother. So let's try this. So we have our B tree, and at the start anyway, that's going to be essentially an empty object. And we're going to have X, and that's going to be a reference, maybe A, B, C in memory, and it's essentially going to be pointing to that. And we're going to have Y, and it's going to be D, E, F. And in theory, we also want that to point to the B tree. We'll call it, we'll say that's at address 000. But what's actually happening is, at least according to our tests that we've done, this might be at 100. This is creating Y as a reference to a new object. So this is being cloned somewhere in theory. And we can confirm that if we actually find the location that it gets cloned at. And that location is in the declaration as I was playing around. And that makes sense. So essentially when we're performing this action of assigning X to Y, it's kind of the only place, because we've simplified the test as much as possible. This is kind of the only place really that the clone can occur, and we can see it here as well. So this was an oversight of mine. I was cloning the value itself, the locked value that we had gotten from the right hand side, the V that's going in here. Whereas really what should have been done is to clone, this is the reference to the object. And in fact, because we own the value V here, we don't even need a clone at that point. So we can replace that V with the object, or the object reference rather. And if I go ahead and comment out all of these print statements, in fact, I'll just remove them entirely and rerun the code. We don't need that anymore, and we'll do it down here as well, v.v. Line either, but basically we can see age 30 and age 30 both in the target object and the original object. So we can see that we copied the reference as expected, and I'll go ahead and rerun that without the extra debugging symbols as well. Oh, thanks for the question. How many coding languages do you know? I mean, it's a tricky one, because like if I were to try and just write in any of the languages I've used right off the bat, I would probably have a hard time. I suppose I've written non-trivial projects in about, I guess, a little over 20 different languages. But when you account for things like, you know, C family languages and object-oriented languages and things like that, there's so much overlap with a lot of them that you can kind of almost use them interchangeably. But yeah, I guess ballpark 20. Well, it's like I say, when you break it down, there are lots of languages that are quite similar in a lot of ways, but I have tried to play around with them so that you're actually using the detail, like try to use the language idiomatically. Now, some languages have so much crossover, like say C# and Java, that you can kind of just use them interchangeably, but I try to, when I do projects in them, work to the strengths of the languages. But to be honest, yeah, even if you know two, like I would say there are lots of languages that I've used that I enjoy using, or I've enjoyed learning them because they help you think differently about programming. But I wouldn't say that they necessarily, they're not ones that I would probably use day to day on a project, except just to focus on learning the language. They wouldn't be, I would say, as practical, but that's down to the individual as well. Well, that's exactly it. I mean, I would say it's much, when I was learning programming anyway, or at least particularly in college, I was kind of inspired to learn different languages so that I could pick the one that worked best for me, because I wanted to do everything and try everything. But if you have, I think the most practical thing to do in a lot of ways, in a lot of scenarios, is to figure out what it is you want to work on and focus on that. And yeah, if you're going to be making games and that's your focus, is to actually build something useful, then absolutely Lua and C++ make so much sense in that context. You're less likely to use things like, I don't know, Haskell or OCaml or something like that. Not that you can't use those, but when you're doing that, your focus is nearly on, I want to write games in those languages because I want to prove that you can write games in those languages, and I have fun programming in that way, rather than I have a concept for a game that I want to see fulfilled and I want to make it efficient and optimal and use best practices and things like that. So it depends on what your goals are. I always try to bring it back to goals, especially when computer science as a general field is so broad and there are so many avenues you can go down that you really do have to pick your battles. But with that said, so we can see that resolves that issue. However, I still have this locked source that I'm also cloning, and I haven't tried this, but I would guess that if I run all the tests with this new improvement, we can see that there are some tests that are still failing. So we have the assignment ones, and in fact, where is parameter mutation 1? That's just that I changed the output. But for a number of these variables, assign 1, 2, and 3, actually I'm kind of surprised that those aren't fixed. And in fact, I haven't run all of these tests again. So maybe I've only fixed a small part of the issue and I haven't solved it completely. So we have X, Y, and Z, and let's see, assignment 1. We've assigned 2, assign 1. So assign 1 is outputting variables assign. Oh, I'm looking at assign 2. And it seems to be only outputting one value. Maybe I'll just run that again. Maybe I'm reading it wrong. No worries. Thanks for tuning in, and yeah, hope to have you again. So what is the output? Okay, so the standard output is 2.2 instead of 2.1. So in this case, we're updating the value of x to 2, and now it's affecting y as well. So in this case, okay, interesting. This isn't to do with I was expecting some functions to fail, because of this locked source, and I wanted to demonstrate that, but it looks like I don't see any actual failures with functions other than the one that I changed the values for. So how to resolve this one then? So first off, what I'll do is I'll comment out these. I'll turn those two cases into their own new test case. But when I save that, that should resolve that function. But I kind of want to make a new function that will highlight the problem with that, which is that the source object gets cloned. But to be honest, if it's not getting flagged by existing tests, especially these ones, although those aren't acting on source. Let's see, this functions. Yeah, I feel like one of those would catch that if there was still an error, but for the moment anyway, I'm still going to just have, I think, source would probably be it. It might have to be source.v. To clone there, but in this case it'll actually be cloning the arc mutex, which we can see exists here, or yeah, it's going to be a valref. Let me just double check value. And a valref is an arc mutex, so that's fine to clone. But we're still getting these failures, so maybe I was a bit premature. I should have done a bit more debugging or a bit more testing before I jumped onto the stream with the solution. But let's see, can I resolve this one? So that's in variables, and we have assign 1. So x is equal to 1, y is equal to x. So it's tricky because we do want to clone, or we do want to clone the reference, but we don't want to clone the we don't want to clone the box itself. We want to introduce a new box into the situation. And we can see in basically all of these tests that the values are just being duplicated the whole time. So it's just 2, 2, 2, 2 across the board. And is that the same in op assignment? It looks like it. It looks like the output is the same. So let's start off with these assignments. So we have 1 is being declared, x is being declared as 1. Locked source, we don't need that anymore. Yeah, we're introducing a new val ref. Do I need to actually clone these guys? That might be what's going wrong there. No. So we have 1 being assigned to x, and then x is being assigned to y, and then 2 is being put in this box. Could it be that when I'm dereferencing x, to assign 2 to it, that I'm actually digging into the value? That doesn't make sense to me. When I unlock, when I do an assignment, so we're dealing with ints. go ahead and try that. Okay, so we have an address when we're performing an assignment, and we're getting the address of X. Let's see what these give us when we're declaring values. So we've declared print in our global scope, and then when we declare X, it's a mutex at this address, and Y has the same reference. Is it absolutely the same? Yes. So how do I create a new instance? So a different pointer, but to the same item. Or is it a case of doing whenever it's whenever there is a declaration or an assignment, that it does a shallow copy, i.e. of a pointer, so to speak, if it's a list or an object, but then if it's a primitive type, the value gets copied. That might be what needs to get done. Yeah, I think so. And that would need to be done for both declarations and assignments and throughout the bind package as well. Now, I also want to be careful because I don't want to do a shallow copy of objects and lists, in the sense that whenever we do an assignment, it's a new instance of the root, because we get back to the issue I had before. I'm surprised that there aren't more tests failing as a result of this issue, but that may just be because, again, the tests aren't comprehensive enough. So if I changed the test to here, to say, let's see, so first of all, let's do this, and this will probably give the same issue, and this will be an independent test as well. Yeah, so that gives 2 as the output, which is incorrect. And now we want to do fn f and in this case the output should be 1, but it's possible that it will be output as 2 based on what we've seen so far. Yeah, exactly. So that issue exists in kind of all the implementations of binding. So yeah, how will I get around that? I'm just thinking copying the value and reference address makes sense, but is it a little hacky? Yeah, and it's the same address across the board for X, Y, and the item that's getting updated to 2. I'm still a bit surprised at that. So if I go, so VV is the original. And if I do that, So that will be before and after the initialization of the new value. And that kind of makes sense because we're giving it the original v. And so but if I do that, like if I do a clone, I would be expecting the second value to be different. Like and I'm just going to comment all of this out. I'm just going to rely on the declaration of print. Not sure will that compile. Yeah, borrowed after move. I'll just do that. Should be fine. Just debugging at the moment anyway. Okay, so in this case, the mutex guard or the mutex is the same address for both. If I do a clone, it's still the same. And that's not really what I want or necessarily expect. Yeah, they're the same address. That's something to remember as well, is that it's not cloning the mutex necessarily, it's cloning the arc. Yeah, I might need to do another bit of debugging offline to figure out what's going on here, but at least we're, in theory, a little bit forward because we have addressed the issue where, well, actually, it's all kind of coming back to the same place. If I clone the arc mutex, then, or yeah, if I do too shallow of, or if I do a shallow clone, yeah, if it's too shallow, no, if it's too deep, then I get a copy of the object, and when I update the object from the second place, it'll only update that new object and not the original. If the clone is too shallow, then both objects are, or both variables are referring to the same item, and updating one will update the other even though it's a value rather than an object. So there's surely a sweet spot in between where we can get the functionality that we want, whether that needs to be handled somewhat manually case by case so that we actually dig into the item and say, okay, well, if it's a value, then we do a copy. If it's an object, then we don't. Yeah, we'll need to see. But for the moment, that's where I'm going to leave it for today. As always, thanks to everyone who commented in and checked out the stream, and I'll talk to you again. Take care.